Hello, everyone. I'm audible. So, fine, guys. I think I'm audible to everyone of you, right? Okay. So, I think we can start with the class. Yeah. So, let's start. So, let me share my whiteboard with all of you. And I believe my whiteboard is visible to all of you, right? Okay. Now, so in today's class, we are going to talk about algorithm called as a decision tree, right? So this is again a different kind of algorithm, works in a complete different way and way more powerful than your logistic regression that we have discussed, or you can say for a classification task, and way more powerful than a linear regression that we have discussed. So let's try to understand how this decision tree is going to work and what in all mathematical concepts will be involved, right? So there are like so many things that we are going to discuss in today's class with respect to a decision tree and a respective topic, right? So fine, guys, let's try to understand. So someone is saying my audio is lost. Is it Srinivas? Is saying my audio is lost. David is saying yesterday task dataset link not added in our dashboard. So David, so I think it's added, but it's available inside your notebook. So if you will go inside your notebook, you will be able to find out. Yeah. So it's added. Audio is fine. Thank you, guys. Thanks for like clarification. Yes. Okay. So now let's try to understand that what is this decision tree and what kind of advantages I will be able to get and what kind of a mathematics which will be involved. This topic is very, very important topic as far as your interview is concerned, right? So it is going to play a very important role when you will try to give an interview or going forward when you will try to build a model. So in both the way, it's very, very important. Again, mathematical concept behind this decision tree is very important. So let's try to understand these things. And for sure, you have to like sit for next 3 hours peacefully. Then only you will be able to understand all the topics. Otherwise, you will have to revise from our recordings. So try to understand everything in a class itself. That will be a better idea. Okay. So fine, let's try to understand what is this decision tree and what kind of advantages I will be able to get if I'm trying to build a model with the help of decision tree. So let me write it down. Decision tree. And there are so many mathematical concepts, so much of mathematical things will come in between when I'm going to talk about a decision tree. So it will be better if you can take a note, and then from that note, so it will be easier for you to like go for the revision. Yes. So a decision tree is another algorithm that we can try to use for a regression task as well as classification task. I think we all are aware about the regression task and a classification task and what is a difference and what kind of cases we used to handle in case of a regression and in case of a classification. So decision tree is so much powerful, and again for sure it's much more powerful than your linear regression as well as a logistics that we have discussed. So linear regression we have discussed for a regression task, and logistics we have discussed for a classification task, where we can try to classify maybe a binary data, or maybe we can try to classify a like a multi-class classification. So all these things are possible in case of a decision tree in a easiest possible way. Again, implementation wise, it's not tough, but what you have to understand over here is a mathematical concept, which is little bit tough as compared to an implementation. But yes, like I said, so it is going to give you a more power. It is going to give you a more flexibility when you will try to train a model. Yeah. So in case of a classification, so we have seen that there will be a n number of classes, and then there will be a column values, or there will be an attribute. So based on the attributes that you are going to give as an input, it is supposed to give you a class, whether it belongs to a class number 0, 1, 2, 3, 4, A, B, C, D, X, Y, Z, or whatever it is. And in case of a regression task, so we always try to find out a numerical value that, okay, fine. So if this is the attribute or this is the input that I'm going to provide, so this may be the output in terms of a numerical or exact value or real values that we all will be able to get. So let's try to understand that how this new algorithms are going to work, and new algorithms is going to give you this kind of a flexibility. So let's suppose I'll just take one simple case over here, right? So let's suppose if I'm planning to attend this class, right? So you all are attending this full stack data science class. So how you will be able to make a decision that today's class I'm supposed to attend and I'm not supposed to attend, or maybe you all have joined this class, right? How you will be able to decide that, okay, I'm supposed to sit inside this class for next 3 hours, or maybe I'll drop off in between. So here you can try to write maybe if else kind of a condition. I think we all know how to write if else kind of a condition. So here you will write if else kind of a condition. So maybe in this way you can write a if else kind of a condition. So if class is interesting, right? Or maybe if yeah, so class, the very layman example, class is interesting, right? So if yes, then I will try to make a decision, continue, right? If not, so in that case, if no, so in that case, I'll drop in between a class. So based on that, you will try to decide so whether you should continue with the classes or you are not supposed to continue with the classes, right? If you are continuing with the class, right, then you will end up learning a mathematical intuition behind a decision tree. If yes, right, if you will continue, and then again, so if you will continue, so continue is equal to yes. So in that case, you will end up learning decision tree over here. And if no, if you are going to a drop off, then here, so you can try to decide that there won't be any kind of a learning or no decision tree learning. So what we have done over here, we have taken a very simple case in this particular place. So where based on maybe a situation and based on a scenario, so we are going to divide, and then finally we are able to make a decision that whether I will be able to learn decision tree concept or whether I won't be able to learn a decision tree concept. So in a final layer, in this layer, you will be able to make a conclusion that whether I will be able to learn decision tree or whether I won't be able to learn a decision tree. In a very last stage, you are able to make a decision in terms of learning a decision tree. But in every step, in every layer, so you are trying to make certain decisions, and based on that, so you are trying to distribute or you are going to write some sort of a condition, right? So again, continue is equal to yes or continue is equal to no. So in this way, we are just trying to make this kind of a statement. So hope this statement or this intuition is clear to all of you. So in the same way, right? So in the similar manner, decision tree works. So whenever you will try to give a data, right? So whenever you will try to give a data, it will try to separate your data set in this manner, in maybe just by using if else statement. As of now, you can try to decide, but yeah, decision tree works in a different way by using some different sort of a mathematics that we will discuss in a later stage. But decision tree actually divides a data first of all, and then in a very last layer you will be able to get your classes or you will be able to get your regression. So we'll try to understand how regression works, but yeah, so this is how it is going to work in case of a classification problem. And finally, you will end up getting what? So you will end up getting a classes that, okay, so I will learn decision tree or I will not be able to learn a decision tree. In a very simple way, this is what I can explain you that about a decision tree, that yeah, this is how it is going to work. Now, so like I said, and like I have mentioned, that decision tree is not the algorithm, not the algorithm which can work only with a classification, but on top of it, it is going to work even with the classification. So sorry. So decision tree is not an algorithm which can only work with the classification, as I have shown, or the kind of example which I have given to you, but it also works with respect to a regression. So how it is going to work with the regression, we will try to understand once we can understand how tree will be created. So the whole idea or the things that you are supposed to learn over here is how it is going to create a tree, how it is going to divide a data, how it is going to give me a final classes by using a very last node that we have over here. So I think we all are familiar with a basic of the tree, right? So there will be multiple branches we can try to create. If I'm talking about a binary tree, so on each and every label, so there will be a multiple branches which will be created over here, and the final node will be responsible for giving you a final class, maybe yes decision, a no decision, and yes decision, this kind of a things which is going to happen. But how we create a tree, right? So unless and until we are not aware about it, for sure I will not be able to utilize this decision tree, and I won't be able to understand an algorithm. That is one thing. Second thing is, so here I'm saying that it is going to divide a data, right? It is going to divide a data each and every time. So half portion of the data set you will be able to see in one section, and half the data set you will be able to see in other sections, or whatever decision you are going to make. So half of the decision you are going to see in one section, another decision you will be able to see in another section. So how it is dividing this data, how it is creating a node, how it will be able to reach out to the final node, which we say as a leaf node. So this task, I think once we will be able to understand a mathematical concept behind it, we all will be able to understand this particular part, right? So that will be the agenda for today's class, right? Now, so it looks like a neural network, but no, it is not a neural network at all. So concept behind a neural network is completely different. It's not at all similar with respect to a decision tree. It's completely different. So once you will be able to understand, I think you can like understand this entire part. So here, the major task over here is that how we can try to divide, how we can try to create a tree, or maybe a node, or maybe a leaf node I can try to create. Now to do that, so maybe I can consider one of the data set, and then with respect to that data set, I can try to explain you exact same thing, that how these things will be done. So let's try to take a new notebook over here, and let's try to consider one of the data set which we can utilize for our construction of a tree. So this is the data set which I'm going to take. So is there any option where we can insert some of the images? Okay, so I believe there is no option where I can insert an image over here. Fine, I'll just create a data set, and then I'll try to explain you. So let's suppose this is a data set that we have over here. This is the data set. And in this data set, we have 3 columns. We have 3 columns over here. One column is, let's suppose, class column. Another column is, let's suppose, we have a gender column. And another column that we have is stay in hostel. Okay, fine. So there are 3 columns that we have. Now class wise, so we have a multiple data set. Let me create it. Okay. So we have a class 9, we have class 10, we have class 8, we have a class 8 over here, then we have 9, then we have 10, then we have 11, then again we have 11, and then we have 8, we have 9, we have 11, we have 11, then we have 10, and then we have 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I believe 13 data set we have. We have a male, we have a female, we have a female, again we have a female, then we have a male, then we have a male and female, then we have a male, then we have a female, then we have a male, we have a male, we have a male, and then female, and we have male. And here, so we have yes, staying in hostel, no, not staying in hostel, yes, and then we have like a no, and then we have a yes, then we have no, then we have yes, 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 and then we have no, then we have no, then yes, no, yes. So this is the data set that we have. Now, in this data set, class is given to me, gender is given to me, or whether you are going to stay in hostel or whether you are not going to stay in hostel. So these are the things which is given to me, right? So class, gender, and whether I'm going to stay in hostel or not. As we can see over here very clearly, that class and gender is nothing but it's a feature or it's a attribute based on that. So maybe so this decision has been taken, or maybe they have opted for a hostel, or maybe they have not opted for the hostel. So this is the data set which is given to me. Now I have to solve this problem, and I have to solve this problem in such a way that if, let's suppose, class is given as maybe, so class is given as maybe like class 8, and so if class is given as 8 and gender is equal to female, right? So whether she is going to stay in hostel or whether she is not going to stay in hostel, we are supposed to make a decision, right? So can I say that just by looking into a data set, you will be able to give me an answer, right? But what is our probability? Because sometimes or somewhere, so 8 class female, yes, 8 class female, no, right? And 8 class female, yes, somewhere is given to me. So again, 8 class female, yes, 8 class female, no, 8 class female, yes, is given to me. So again, maybe you can go ahead with the probability that, okay, fine. So there is a very high probability that 8 class female may stay in a hostel. So fine, my answer will be yes in that case, because probability is very, very high. But how I will be able to take this decision, or how I will be able to build some of the models by using a decision tree which will be able to make this decision. So maybe intuition wise, I can try to create this kind of a tree or this kind of a structure that, okay, so let's suppose this is a node, right? So first of all, if this node is having a male, so if male is given to me and if it is yes, right? So if male is yes, so means data set is male, right? And then we can try to divide, okay, fine. So male is no, possible, right? And again, if male is yes, then in that case, maybe this person or this person is available in a class 9 or maybe class 8, class 9, maybe class 8, maybe in class 10, or maybe in class 11. There is a possibility. If it's not male, in that case, for sure, it's a female, right? So in that case, it will be a female, I believe. And then again, female can be available in class 8, 9, 10, 11. There is a possibility. So if it is male, yes, and class 8, 9, 10, 11, right? If it is not a male, it's a female, then it's 8, 9, 10, and 11, right? So if male, yes, and it is in a class 8, and if it is yes, right? So maybe I can try to route these things. So class 8 male. So where is a class 8 male? Do we have any class 8 male? So I think we don't have any kind of a class 8 male over here, right? So maybe I won't be able to make a decision. Then class 9 male. So class 9 male, in that case, yes, he is going to stay in hostel. So here I'm not able to make a decision. Then if this is yes, right, this is yes, so in that case I will be able to make a decision. So yes, this person may stay in hostel. So in this way I can try to I can try to build this entire hierarchical order, or at the time of making a decision, so I can just try to go through each and every node, and then I will be able to make a final decision, or maybe I will not be able to make a final decision. So if this kind of a hierarchy I will be able to create out of this particular data set, there is a very high chance that I will be able to do a classification. I will be able to build a model. But here I have just separated my data based on a gender column, right? So male, yes or no. And based on that, so I'm trying to divide my data. There is a different possibilities, right? So maybe I can try to divide my data based out of the classes itself. So maybe I can try to build another decision tree over here, right? So where I can try to divide a data based on a class. And then in that case, I can try to create maybe a 4 node over here, as we have a 4 different kind of a data. So for class 8, maybe for class 9, and then for class 10, and maybe for class 11, right? Maybe for class 11. Then again, so here we can try to divide a data based out of the gender, and then we can try to reach out to the conclusion. So in this particular place, I have started with the gender column. In this particular place, I have started with the class column. So in this way, there are many different kind of possibilities available by which I can end up building this kind of a tree structure, or this kind of a hierarchy. But again, I'm not able to find out a robust way, or maybe I'm not able to find out an approach by which I can identify who will be a very first node, which column or which attribute is going to create a very first node, then second node, then third node, then fourth node, or how a separation of the data set is going to work. I'm not sure about it actually, right? So I'm not able to identify these kind of approaches or these kind of things. So in decision tree, this is a very first problem we all are going to face. We all are aware about it, that okay, fine, maybe based on if else kind of a statement, I will be able to build this kind of a hierarchy. That's completely fine. But who is going to be the first one? Who is going to be the parent node? Who is going to be the child node? Who is going to be the child of child node, right? So I'm not sure about it, and what kind of a data division I will be able to create in between. So that is something, and this is where a whole lot of mathematics is like the whole lot of mathematics you all are supposed to learn, or you all are supposed to understand. Now, what kind of a mathematics I'm supposed to understand, or I'm supposed to learn over here? So let's try to understand. Now, to create this kind of a tree, so the researcher has identified a couple of ways. It's not like there is only one way. So researcher has identified couple of a way by which I will be able to create this kind of a decision tree, or by which I will be able to maintain this kind of a hierarchy. So there is a way called as information gain, and there is a way called as Gini. Again, there are other ways as well, so I'll be talking about it, but there is something called as information gain, and there is something called as a Gini, by which I will be able to perform these kind of operations. And my whole idea and objective over here is to create a tree, create this hierarchy. Once I will be able to create a tree, or I will be able to create a hierarchy, my work will be done, and I will be able to make a decision. I will be in a position to make a decision. So let's try to understand those approaches. So I think problem statement is clear to everyone. The problem statement is how to build a tree. I'm not sure about like whatever I have written over here, right? I'm not actually sure about it. So I don't even know that whatever I have mentioned over here is correct or maybe incorrect, right? Or whether this hierarchy is a correct, whatever hierarchy which I have mentioned over here, or whatever data split I have done over here is a correct one or it's an incorrect one. I'm literally not aware about it. And that is the answer which we all are supposed to find out, that how to select a root node, then a child node, then child will become a root node, and then child of child, then child of child. Till what label I'm supposed to split my data, or till what label. So maybe label 1, label 2, label 3, label 4, label 100. So whether it is possible or it's not possible to create a data till label 100, even if we are creating a data set or maybe hierarchy till label 100, is it required or not? Unnecessarily, if we are going to increase our number of the labels, so for sure unnecessarily it is going to make our algorithm more complex at the time of prediction. So whether we are supposed to do that or not. So all these questions that we have in our mind, so I think we are supposed to find out an answer, and we will be able to find out an answer once we will be able to learn how tree will be created, right? So that is the only way by which you all can know and we all can understand that, okay, fine. So now I know how tree can be created. So all of my questions are answered now, right? So hope problem statement is clear to all of you. What is a problem that we have with respect to a decision tree? Is it fine? Yes. So this is a problem. Now, as of now, I'm just talking about the problem. I haven't discussed about even a single solution over here, right? So this is just a problem. I will be able to create a tree, right? So if I'll give you this data set and if I'll like ask 10 people to create a tree, they all will be able to create a tree, right? Some kind of a if else kind of a statement, and all those 10 people are going to create a 10 different tree. Now, so I don't even know that who has created a correct one and who has created an incorrect one. So in that case, it will be a difficult task for me to do an evaluation. So if I can't rely on that, if I can't evaluate a tree created by you, so for sure, that kind of a solution I'm not going to accept. So I'm supposed to create a kind of a solution which will be accepted by all of us. We all can rely on this one, and we all will be able to accept that particular solution based on this data set which is given to me. So fine, let's start talking about it. A solution part, right? So far it was just a problem part that we have discussed. So let me erase this entire things, right? Except a data set, so that we can try to do a calculation over here. Okay, now let's try to understand some mathematics behind this one. So here, as we can clearly see that we have a class and gender, and whether they are going to stay in hostel or they are not going to stay in hostel. We have to make a decision, and if some new data set is given to me, and based out of that decision, and again, let's suppose here we have 2 attributes as a feature, right? Going forward, let's suppose there are hundreds of attributes. Then what you will do, right? So out of this 100 number of features, you are supposed to select, you are supposed to decide that which one is going to be a root node. And I think we all can decide that particular part. So there is a mathematics, or there is a formula called as Gini. So first of all, try to understand this formula and then try to do some calculation, and then we can try to understand its like a theory. So let's suppose I'm talking about a mathematical concept called as Gini. So what this Gini is? So Gini is nothing but 1 minus summation of I is equal to 1 till C and a pi square. This is what a Gini says. Now, why we are using this formula, or what kind of advantages I will be able to get, right? So this is a formula that we have. Just try to remember it just for now, for next half an hour, 1 hour. So try to remember this particular formula called as Gini. So 1 minus summation of probability square. Now, probability of what? I literally don't know as of now, right? So probability of what we are supposed to like find out over here, and what is the meaning of Gini, or maybe how we can try to utilize this Gini in terms of making a trees out of it, right? What is the restrictions behind a Gini? What is the limitations of a Gini? What is the drawback of Gini? I think we will be able to identify answer of each and everything. So now here, if I'm talking about a column number 1, So let's suppose if I'm talking about a column class, right? Okay. So let's suppose if I have written over here, so class. So how many different classes we have, first of all, in our data set? Can I say we have class 8, right? We have class 8, we have class 9, we have class 10, and we have class 11. So try to participate, guys, all of you, right? Even if it is a very small thing, try to participate. In that way you all can understand, right? Okay, so how many classes we have? I'm just talking about the very first column. The very first column is class column, right? So we have 4 distinct classes over here. Now if I'll ask you, so stay in hostel, right? So stay in hostel, right? So can I say that for this class, right? For this class, so some of these students who is in class 9, class 8, class 10, class 11, so they are staying in hostel. Some of them are not staying in hostel. Agree, everyone? So some of them from class 8 are staying in hostel. Some of them are not staying in hostel. So fine, no issue. So how many of them are in class 8 and they are staying in hostel, and how many of them are in class 8 and they are not staying in hostel? So can I say that two-person who is in class 8, two-person, right? So maybe this person, yes, this is no, this is yes. So these two-person who is in class 8, so they are staying in hostel, and there is one person who is not staying in hostel. Fine. Now, how many people are there in class 9 who is staying in hostel, and how many people are there in class 9 who is not staying in hostel? So yes is equal to, so how many people are there in class 9? So 1 yes, 2 yes, this one is no. So 2 yes and no is equal to 1. Again, similarly for class 10, how many people are staying in hostel? So we have like 10 no, 10 no, and then we have like a 10 no and 10 yes. So only one people is staying in hostel and no wise. So we have 3 as a count who is not staying in hostel, who is in class 10. Now how many people are in class 11? Out of them they are staying in hostel. So class 11, if I'll say, so we have 1 yes, 2 yes, 3 yes. So 3 yes. And what is a count for no? So I believe count for no is equal to 1 we have. So 3 is to 1. Fine. This is the data that we have created. Fine. Now what is our total value? So total value over here. So total value, yes plus no is equal to 2 plus 1, 3, 2 plus 1, 3, 3 plus 1, 4, right? 3 plus 1 is equal to 4. So in total, we have how many data set? We have in total 14 data set, right? Now, if I'll ask you, right? Now, if I'll ask you P of yes and P of no over here, right? So probability of, right? Probability of a person to being in class 8, but they are staying in hostel, right? So out of 3 people who is in class 8, 2 people are staying in hostel, right? So probability of yes is equal to 2 by 3. Probability of no is equal to 1 by 3, I believe. Then for this one, for class 9, so out of 3 people, 2 people are staying in hostel. So fine, it is going to be 2 by 3, and not staying in hostel, probability is equal to 1 by 3. Now probability of like a person who is staying in class sorry, who is in class 10, and the probability of yes, they are staying in hostel. So can I say like it will be 1 by 4, and this is going to be 3 by 4? No, right? Now 3 by 4 and 1 by 4. So fine, we all are able to calculate a probability in this particular place. So I think this table is correct, right? All of us are good in terms of creating this table. Yes, we all are able to follow. Fine. Now what we can do is, so we can try to calculate a Gini. We can try to calculate a Gini for each and every individual classes over here. So I think formula is written. So how to calculate a Gini? As of now, just try to calculate, right? So what about the last record? So have I given like a data set for that last record? So can I say that last record I have given you as a question? I think you have joined a little bit late. That's the reason. So you are asking this question. Otherwise, you won't ask this question. So I have not given any kind of input, right? So we are supposed to do a prediction for that one. Now, so what we can do is, so maybe we can try to calculate a Gini, right? So Gini for class 8, if I have to calculate Gini for class 8, again, class 8, 9, 10, 11. So we can try to calculate a Gini. So Gini says that it's 1 minus summation of a probability square, right? Now, what kind of a summations, right? What kind of a summations that we are looking for over here, or what kind of a final outcome that we are expecting in this particular place, right? So let's try to identify, or let's try to understand even that particular part. So here we have probability yes, as well as probability no. In that case, so this I is equal to 1 to C, it's nothing but I is equal to 1 till class C. So whatever classes that we have, like yes and no class as we have as of now, let's suppose going forward we have a 4 to 5 classes. So in that case, 1 minus a summation of a probability of all the classes, right? So here we have 2 classes. So that's the reason. So it's written as summation 2 till C. Now here what I can write down is, so for class 8, 1 minus, so probability of summation of ES. So probability of summation of ES square, right? Minus, I can try to write down, so probability of no square, right? So this is something that we can write it down. Now here, 1 minus, so what is our probability of ES? So probability of ES is 2 by 3 for class 8. So of square minus, what is the probability of no? 1 by 3. 1 by 3 of square. So now what will be the final outcome for this one? So what is the final outcome that I can say in this particular place? So can I say that it is going to be 4 by 9? 4 by 9. So Gini of class 8 is equal to 4 by 9. Now, if I'll try to calculate Gini of class 9, so in that case, 1 minus 2 by 3 square. So 2 by 3 square minus 1 by 3 square is equal to, again, 4 by 9, same as the class 8, 4 by 9. What is a Gini of class 10? So Gini of class 10 is nothing but 1 minus 1 by 4 of square minus 3 by 4 square. Now, what will be the answer for this one? So class 10. So can I say that for class 10, it is going to be 6 by 16, I believe, right? So 6 by 16. So we can try to divide it by 2. So maybe I can try to get 3 by 8, right? Or I can write down 6 by 16 or 3 by 8. I can try to write it down. Now, Gini of class 11. Now, what is a Gini of class 11? So 1 minus 3 by 4 square minus 1 by 4 square. It is going to be same, I believe, right? 6 by 16 or 3 by 8. Simple. So this is something that I will be able to get. So I'm able to find out a Gini of individual Gini of class 8, class 9, class 10, as well as class 11. Now here, what we try to find out is, so we try to calculate a weighted sum of each and every Gini for each and every values that we have calculated. So weighted sum of each and everything we used to calculate. So if we have to calculate a Gini of this class, as of now, inside a class 8, 9, 10, 11. So for these individual attribute, we are trying to find out a Gini. But if we have to calculate a Gini of, or a complete Gini of a class attribute, a class column, not just for 8, 9, 10, 11. So in that case, I can try to write it down in this way. So Gini of this entire column is going to be, so Gini of, so G of entire column. So C is representing a column, right? So we can try to write it down in this way that, okay, fine. So number of instances for class n, number of instance class divided by total number of instance into Guinea of class, Guinea of the respective class we can talk about. So if we are able to calculate summation of it, so for sure I will be able to calculate a Guinea of a particular column. That is our objective. So Guinea for this entire column we have to calculate. Let's try to understand. Again, calculation wise, it's not that tough. It's very, very easy, right? So we can try to calculate it easily in this particular way. So let's try to understand it. So if I have to calculate a Guinea of this entire things, a Guinea of a class, so maybe I can try to write it down. So let me take a different color over here. So Guinea of entire class is equal to, so what is the Guinea of the entire class? So Guinea of entire class is nothing but respective instances in class 8 divided by total number of instances. So total number of instances, let's suppose I'm representing by T into a Guinea of a class 8, Guinea of class 8 plus instances which belongs to class 9 divided by total into Guinea of class 9 plus instances of class 10 divided by total into Guinea of 10 plus instances by total Guinea of class 11. Now, how many instances we have in a class 8? Any idea? How many instances we have in class 8? Can I say total instance in class 8 is equal to 3? Fine. 3. What is our total instances we have? Yes, 14. What is a Guinea of class 8? Just a class 8. So can I say, so Guinea of class 8 is nothing but 4 by 9, right? 4 by 9 plus what is a total instance we have in class 9? Can I say again 3, right? What is a total instance we have? So 14 into what is the Guinea of class 9? Guinea of class 9 is equal to 4 by 9. Fine. We are able to write it down. Now, what is the total instance we have in class 10? So can I say that instances of class 10 is equal to 4? What is our total instance? 14. What is a Guinea of class 10? So can I say that 6 by 16? This is what we have written. Now, so what is a Guinea of class 11? So sorry, what is the total number of instances in class 11? So can I say 4? What is our total instances? So 14. What is a Guinea of class 11? So 6 by 16, right? Now just try to calculate what is a Guinea of a class. Just try to do a calculation, guys, quickly. So 0.404, right? So Supreet is saying that 0.404 is a value which I can try to receive. Okay, fine. So 0.4, sorry. So 0.404 is a value I will be able to receive. So find Guinea of this entire column is equal to 0.404. This is what we are able to find out, right? A Guinea of the entire column. So is this approach clear? So we are trying to find out an individual Guinea of each and every categories which is available inside a class, and then we are trying to find out inside one of the column, and then we are trying to find out a Guinea of entire column. So is this procedure good? Are we able to understand this procedure, right? So what's a TV in the column? So total value. I believe you have joined a little bit late. So again, that's the reasons you are not able to understand, right? So it's a total value. So total number of instances that we have in a particular classes. Okay. Now, Fine. So why we minus Pn2? So because we have written summation of, right? So just try to go through this formula. 1 minus summation of I is equal to 1 to for entire classes, 1 to all the classes. So how many classes we have? Can I say we have a yes and no, right? That is the reason. So we are trying to do this summation or this operations. Yes. So C dash is nothing but you can say like for a respective classes, subset of the class. Now, I'm just representing 8, 9, 10, 11 as a C dash. That's it. Okay, so here Guinea for this one is nothing but, so Guinea for this one is equal to 0.404. Similarly, so we have another column, right? We have a gender column. So for a gender column, so we will try to find out a same thing, exactly same thing. So I think all of you have taken a note of this entire data set, right? Everyone? Yes, we all have taken a note of this entire data set. Fine. We will try to create a similar kind of a table, right, for this gender column as well. So let's suppose I'm going to work on this gender column, right? So let's suppose gender column, right? So how many genders we have? Can I say either we have a male or we have a female, right? Now, out of which stay in hostel, same approach. Fine. Then total value TV. I'm just trying to represent total value as a TV. And then maybe we can try to represent yes and no. So probability of yes and probability of no. Right? Okay, fine. So now stay in hostel. So there can be yes and there can be no. Right? There can be yes and there can be no over here. Fine. So I'll go back to my data set and I'll look into my data set over here. How many people we have over here as a male, right, who is staying in hostel? How many people we have a male over here who is staying in hostel? Yes. So can I say that in this particular place, so we have a male, right? Male, yes. Male, yes. Male, yes. Then male yes, and then male yes. So we have in total 5 male yes, they are staying in hostel. Fine. So I'll write 5 over here. How many male we have who is not staying in hostel? So can I say that we have like a 3 male who is not staying in hostel? So male no, you will be able to find out here. Male no, you will be able to find out here. And male no, you will be able to find out here, right? So we have 3 male who is not staying in hostel. Similarly, how many female we have who is staying in hostel? So can I say 3 female we have who is staying in hostel? So 1 and then 2 and then 3. So we have 3 female who is staying in hostel, and how many of them are not staying in hostel? So again 3. So 3 female not staying in hostel. What is a total value? A male. So can I say it's 8? What is the total value as a female? So can I say it's a 6? What is in total value? It's equal to 14 over here, right? Now probability of a male staying in hostel. So male staying in hostel is equal to. So can I say that it is going to be 5/8, and probability of male not staying in hostel 3/8, I believe, and probability of female staying in hostel, right? So 3/6. So I can write maybe 1/2 over here, and probability of female not staying in hostel. So 1/2, 3/6, 1/2, right? I can try to write it down. Now, what we are supposed to do? What is the next step? So once we are able to create this table, so what is the next step? So can I say that we are supposed to find out a Gini of male and a female? So what will be a Gini of male? So let's suppose if I'm going to calculate a Gini of male over here. So can I write it down in this way? So 1 minus, right? So probability of 5 means probability of staying male in a hostel 5/8 square minus probability of male not staying in hostel. We have 2 classes, right? So this is square. And what will be a Gini of a female over here? So Gini of female is nothing but 1 minus 1 by 2 square minus 1 by 2 square. Now, what will be an outcome for these two? Yes. So what will be the outcome for male and female? For male, it is going to be 0.47, let's suppose. Or maybe 15 by 32. So I can write it down 15 by 32. And for female, so what is a probability? So for male, this is the probability. And for female, what is the probability? So can I say that 1 by 2 or 0.5? Right? Okay, fine. So for male, this is going to be a 0.468. Again, so as per Satvik, not as per me. So if he has made a mistake, you can suggest me to rectify it. Okay, so fine. Gini we are able to find out. Now we are supposed to calculate what? So can I say that now we are supposed to calculate a Gini of the entire gender column? So what will be the Gini of entire gender column? So Gini of a gender column, right? So Gini of gender column is going to be, so total data available with male 8 divided by total number of data into Gini of male plus total data available in female into 1 by 2. Now what is the value? 0.482. Okay, so 0.482. So for gender column, we are able to find out Gini is equal to 0.482, right? So this is the values we are able to find out. So who is having the highest Gini and who is having the lowest Gini? So who is having the highest Gini? So again, both the questions is like a same answer is going to be same. So can I say that gender column is having a higher Gini values as compared to a class column, right? Or I can say class column is having a lowest Gini value as compared to a gender, right? So here, let me tell you something about a Gini now. So I think we all are good with the calculation, right? Calculation of a Gini. Yes, everyone. So how we are doing a calculation for a Gini indexing? Yeah. So we are good with now with this like a detailed elaborated like a calculation. So we all are able to understand it. Now Gini is actually called as Gini impurity. So it always tells you that, okay, what is a probability that if this class will be taken or if this attribute will be taken or this column will be taken, right? So what is a probability that it is going to give me a more impurity? So it always try to find out 1 minus probability square. So it's not like probability will be equal to 1 all the time. It always try to give you 1 minus probability square. So 1 minus probability square always says, so here probability of occurrence of classes. So we are trying to subtract what? So we are trying to subtract actually probability of occurrence of this particular or this particular attribute we are trying to find out. So it always tells you that what is a impurity I will be able to get if I'm going to calculate a Gini. So it's called as Gini impurity. So let's suppose my class, gender class is giving me more impurity as compared to my class column. So in that case, which one I'm supposed to select? A column with the more impurity or column with the less impurity? And again, impurity simply means that scatterness, or impurity simply means that if I'm able to find out the exact probability of occurrence of something, that is something called as pure. If I'm not able to find out the exact probability of occurrence of something, that is something called as impure. So which one I'm supposed to select? So a value with a high Gini or value with the low Gini, right? So can I say that I'm supposed to, when I'm talking about the impurity, and Gini is something called as Gini impurity, right? So I'm supposed to select something which is giving me a low impurity, right? As compared to something which is giving me a very high impurity. So can I say that in this case, my class column is giving me a less Gini value, which is less impure as compared to my gender? Means probability I can try to define for this class column in a better way as compared to a gender column. So probability of occurrence of 8, 9, 10, 11, I can try to define in a better way as compared to male and female with respect to the stay in hostel or not stay in hostel. So in that case, we can try to select class column, and class column should be my option, right? So I'm supposed to select over here that, okay, I'm supposed to select over here class column. I'm not supposed to select a gender column. So if I have to create a root node, right? If I have to start making a division, so in case of a Gini, what I will do, so I'll try to select that particular value which is having a less Gini. So in this case, I will try to select class column as a root node, not as a gender column. So let's suppose hundreds of columns are given to me. What I will do, I'll try to calculate a Gini of all the 100 columns. Then what I will do, so I will try to select only that column which is giving me a less Gini. Is it making sense to everyone? Yes. So we always have to select our columns with a less Gini if we are following a Gini indexing or Gini impurity approach. It simply says that the probability which we are able to find out, right? So probability for this class is less scattered as compared to other classes or as compared to other attributes. So a probability which is less scattered for a particular attribute. So I think we are supposed to select that particular attribute. And in our cases, it's a class, which is telling me this particular story. So fine, no issue. I can try to create, or maybe I can try to create a decision tree based on what? So based on the class. So my very first node is going to be what? A class node, right? Class node. Now, inside a class, if I look into the class, this is what I'm able to decide based on the Gini, because class was giving me a less Gini. So class will be my selection. Now, inside a class, can I say I have 4 different variables or 4 distinct value, right? I have 4 distinct value. So I have actually class 8, right? I have a class 9. I have class 10. And I have class 11. So here we have again a separation, class 8, class 9, class 10, and then we have class 11 over here in this particular place. Fine, no issue. So what I can do is, so I'm just trying to separate my data. So previously we had one big table. Let's suppose this big table, which was my data set. Okay. Now, in a next step, I will try to divide a data. So what in all record we have for class 8? So I'll just try to change my color. So can I say that this record we have for class 8, this record we have for class 8, this record we have for class 8, any other data we have for class 8? No, right? So for class 8, we have these 3 records. So female, 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 all 3 female. So yes, no, yes. Okay. So fine, under class 8, we have 3 data sets. So class 8, class 8, class 8, female, 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 yes, no, yes. Is it correct? This is the only data set we have for class 8. Yes, everyone? Yeah. So this is the only data set we have for class 8. Now for class 9, what is the data set we have? So class 9. So this is my class 9, 1, 2, and 3, I believe. So 999, male, male, and male. Okay. Yes, yes, and no. Fine. I think yes, yes, and no, right? Yeah, if I remember correctly. So I believe it's a yes and then no. Fine. Now for class 10, how many data set we have? 4 data sets. So female, male, female, male. Okay. Okay. And what is the value? So no, 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 and yes. Okay. 3 no, 1 yes. Okay. Now for class 11, I believe we have 4 data sets. So 11 female, male, and then female, male, male, male. Okay. And yes, yes, and no, yes. Fine. No, yes, 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 right. Yes, yes, and no, yes. Okay. So this is our data separations that we have created in this particular place. So can I say that again, I'm able to, like, I'm just trying to get back to the first position. So over there, I have a complete data set over here. So I have a separation of the data set. Yes. So same, can I say, can I make a statement over here that I have just done one thing in this particular place? I have separated a data set. Agree, everyone? I've done nothing. I just separated the data set. So now I have like a 14 records, and now it's like 3, 3, 4, 4. This kind of a records I have. And can I make a statement over here that again we are on a same place, right? So whatever place that we had before, so I think we are on a same places. And again we have a table. Now what we should do? So can I say that for this label, I'm supposed to find out a root node, or this will be a child node of my class node, because class node is my root node that we have selected. So can I say that again, I have to solve the same problem. So again, I have to find out the Guinea, who is going to be the root node. This is something which I'm supposed to find out. Yes. So again, I will try to do a Guinea impurity calculation over here. Again, I will try to do exact similar kind of a things. And then can I say that I will end up dividing my entire data set till a lowest label, right? Okay, so quickly, I'll try to do a calculation for one, right? So one of these things. So let's suppose here we have 888 and female, 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 right? So we have 888 female, female, female. So I think it's a very simple calculation of the Gini. So anyone who can calculate a Gini for like a class column and a gender column quickly? Anyone who can do a calculation? Again, based on the same calculation, right? So here you don't have even two values. So here we have like a very simple, only one values, which is available, right? So can I say that for this gender column, so we can quickly try to calculate a Gini? Yes, guys, quickly calculate it. So just try to follow the same approach, right? And just for this table, calculate a Gini. So here again, I have to decide that who is going to be the node. Okay, so Priyanka is saying 4 by 9. 4 by 9 for what? Okay, class 8. Fine. Class 8.44. GT is saying, Sivan is saying 0.45. Class 9. No, just try to calculate a Gini for class 8. Just for class 8, if you can try to calculate a Gini. And then I believe for gender, it is going to be the same, right? So just for this table, only for one table, class 8 table, right? Try to do a calculation just for class 8 table. What is a Gini for class 8 table? So for a class column, for a gender column. Okay, 4/9, 4/9. Okay. So for both class and gender, can I say that it is going to be a same Gini, right? So it is going to be a same Gini, 4/9. So previously we have already done like a separations of the data based out of the classes, based out of 8. So again, there is no sense of like making a division again. So maybe I can say that, okay, fine. So there is a female. So now next node for this 8th class, next node is going to be what? So next node that we are going to create over here, which is going to be based on a gender. And again, inside a gender, so what we have, so can I say that inside a gender, we just have a female. So there is no separation which is required. Now inside a female, so either we have yes and we have a no, right? So either we have a yes over here and we have a no over here. So can I say that in this way, I can try to break it down, right? So female yes and female no, female yes and female no. Okay. Is it clear now? Yes. So can I say if I'll have to recreate this entire hierarchy or this entire structure, so I can simply say that this will be a class, right? Class. And for class 8, right? So if it is class 8, then it is going to divide from a gender, right? And then out of gender, if it is female, it is getting divided into yes and no kind of a decision. So can I say that I will be able to create this particular branch? So finally, where I'm trying to make a decision, yes and no. So this female, right? So if it is a female, so can I say that half of the decision or probability of finding out yes, if female is in a class 8 is 1/2, and probability of finding out female in class like a not in a hostel is equal to 1/2. Yes. Yeah. So this is something that I will be able to create over here. Similarly, so for a class 9, so here it will be a gender, right? Gender. And then gender wise, so it is going to be male in this particular place. And then if it is male, so it's just yes. Always. It's a very clear yes that we are able to build. Now here, let's suppose for class 10, we are trying to make a division. Now here there is a chances that Gini for this one will be less. So I can try to select a gender, let's suppose. And then we have inside a gender. So we have two branches. We have male and female. So male and female. So in case of a male, we are getting sometime yes, sometime no. So in case of a male, so we are getting sometime yes, sometime no. In case of a female, so we are getting always no. Right? In case of female, we are getting always no. Now, if I'll talk about a class 11, so let's suppose I'm going to divide these things based out of a gender over here. And then inside this one, we have a male as well as we have a female. So we have a male over here. We have a female over here. And then if we have a female, then it's always a yes, I believe. And then if we have a male, so 50-50. There is a yes and there is a no. I'm able to find out. So can I say that I had a very big table and now I'm able to convert this entire table into a kind of a tree? Yes, this kind of a tree. Maybe yes or no here and there. That is completely fine. I think we all can understand this part, right? But can I say that I have just converted that data into a decision tree or kind of a hierarchy, kind of a structure, right? Where in a leaf node, we have a final decision. So whether it is going to be yes or whether it is going to be no. Now I'll give you one simple data, a random data I'm going to give you, right? So let's suppose if I'm giving you a class 11, right? Class 11, so class wise and gender wise, it is going to be, let's suppose, female. Now, whether she is going to stay in hostel and whether she is not going to stay in hostel. So how you are going to make a decision? So whether she is going to stay in a hostel, so what you will do? So you will try to check first of all that, okay, what is there in a root node? Okay, so class is there. Now, what is a class value? So class value is equal to 11 in this particular place. So I will try to follow this path immediately. So am I supposed to check this path, this path, this path, all three paths or all four paths? No. Can I say that I'm just supposed to check this one, class 11, right? So class 11 value is given to me. Then I will come to the gender part. So gender wise, I'm not supposed to go on this side. Can I say I'm supposed to go on this side, right? Female. And what is the outcome which we are able to receive? So we are able to receive actually yes as an outcome. Yes. So we are able to receive yes as an outcome in this particular place. So in this case, what will be my decision? So class 11 female is going to stay in a hostel or not going to stay in a hostel. So I will say she is going to stay in a hostel. I will try to select this particular decision. So this is how prediction will be made in case of a decision tree. So again, if you have a more amount of data, your structure will be more precise and correct, right? Now let's suppose if I have two outcomes. So let's suppose a gender, so class is given you as a 11 and then it is given you as a male. So class 11 and male. In that case, how you will make a decision? Class 11 male, how you are going to make a decision? So can I say that if there, so if you will look into the table, right? The table structure that we have. So over here, can I say that male, male, male? So how many males is having yes? Can I say yes is always having a positive point? So the actual node for this one is going to be yes, it is not going to be this one. At the time of tree creation, we can give this one, but we can try to assign a weightage of yes. So can I say that weightage of yes will be high? Yes. So weightage of yes is going to be high in this particular situation. So if I'm telling you 11 male, in that case, what will the answer? Can I say yes will be the answer? Yeah. So yes will be the answer. So as you will try to create a more precise and concrete separation. So as you can see over here, a final decision always depends upon the way we are going to separate a data, the way we are going to create a table. So as we will try to create a more and more separation, right, our result will be more and more clear and it will give you a less amount of a conflict. As of now, we have just taken a 14 data set, right? And that too very straightforward, simple data set we have taken. And just to understand or just to build this particular decision tree that we have over here. So somewhere we are able to receive a conflict. But as your data set will grow, your accuracy and your separation, because your accuracy just depends upon the separations. So how in a beautiful manner, I'm able to separate an entire structure so that I won't be able to get any kind of a conflict over here, right? So are we able to make a decision by using this tree? How many of you are having a questions over here now with Gini indexing? Can you please tell a calculation for class 10? So calculation of what? So like the previous board you're talking about? Is it okay to say a node will have a new feature every time? No, it's not okay to say that node will be having a new feature every time. There is a possibility that I have divided my data in a first place by class. Again, I can make a division on classes. There is a possibility. Yes. Okay. How to calculate a Gini for class 8? I think we have already done that, right? For class 8, I think we have already calculated the Gini, right? Okay. So if we also have a column age, how do we find a Gini of here? So let me tell you one thing, that Gini is an algorithm which works well with a categorical data. So can I say that in my table we had a categorical data? Yes, so that's the reason. So I started talking about a Gini. Next algorithm that I'm going to talk about is called as entropy and information gain. So in case of entropy and information gain, so it is going to work even with the like a continuous data set. And again, so when I will talk about my implementation, so I'm going to talk about ID3 and a card. So these are the algorithms which accommodates a continuous and a categorical data by using either a Gini or by using a entropy information gain. So this is the idea that we have behind this entire decision tree process, and this is something that we were trying to implement. So after every node, we have to apply a Gini to get the parent classes. Exactly, yes. So every time what we are doing, so we are trying to create a smaller table, or we are trying to create a smaller subset of the data set. So can I say that here we have divided our data, right? So every time we'll have to do the same thing. We'll keep on dividing the data set, right? So here class 8 data separated, 9 data separated, class 10 data separated, 11 data separated, right? So now we have a same data, but into a different multiple chunks. It depends upon the separations that we have created. Yeah. In Gini, we always calculate Y or N with respect to a target column. Y and N with respect to a target column. Yes, that's true. So here in target column itself, we had a Y and N. What will be the output of class 8 male? So what will be the output of class 8 and then male? So output will be undefined over here. As I said, there are certain conflicting points you will be able to see. And that point has arisen just because of insufficiency of the data, right? There is no other things over here you will be able to find out. So as your data will grow, as in a smaller set of the data set, it's very much impossible to take all the combinations. As your data will grow, you will be able to get a refined prediction over here. Why do we have to use a Gini for the second iterations, even when only 2 columns are there? Yeah. So let's suppose I have hundreds of columns. In that case, for sure, we'll have to use out of the 100 column, right? Let's suppose I have a continuous, okay. So in continuous data, Gini is anyhow, it's not applicable, right? So let's suppose we have a categorical data itself, but we have divided this 8 into 801 and 802. So let's suppose I'm trying to make a multiple separation. So 801, 802. So 8 section A, 8 section B. Then again, we'll have to decide this one. So what is the complexity of the decision tree? And it has so many things. Login. So n login will be a complexity of the decision tree at any point of a time, because complexity you are trying to calculate for a training time, but you have to calculate a complexity for a testing time, right? So again, yeah, train complexity as well as train test complexity you can try to define. So training complexity will be high because in every node we are trying to do a calculation, we are trying to separate a data set. But once you will be able to build this structure, so testing time complexity will be log n. So we are just trying to traverse through one of the branches. That's it. In what way Gini is more powerful than a logistic regression? That you will be able to understand when I'll try to conclude a decision tree. What is probability of the class of male yes and no are same? Then which one should we consider? See, like I told you again and again, there is a conflict you can find out in case of insufficiency of the data, right? In a real-time data, this is not things that you will be able to find out. If I'm talking about a millions of records, even if I'm talking about a thousands of record, you will be able to find out a very clear separations. So this conflict doesn't exist in a real-time data. In a Gini index, we always calculate Y. I think I have already answered this question. Why did we a game? I'm not able to understand your question. Can it be only used for classification? So I'll be talking about it, how classification and regression works. As I clearly said, that decision tree has been used for classification as well as regression. So I have not discussed about a regression so far. So once I'll discuss, hope you will be able to get an answer. Can it be only okay? So if data changes, then entire tree structure change, right? Yes, completely. your previous tree structure is not going to work at all, because it will try to form a new tree once again. Again, I'm not clear with the formula. So you are trying to do 1 minus summation of py and 2. So, but you took minus in place. Yes, because summation of whole you are taking, right? If you break the summation, so what will happen? Simple mathematics. Why you are not able to understand this one? I'm not able to understand why you are not able to understand. I have written clearly over here 1 minus summation of p of xi, let's suppose, right? Xi over here of square. So if we have like multiple or xc, multiple classes over here. So if you are going to take these things, so 1 minus p for yes plus p for no. Now if you break this bracket, so what will happen? 1 minus p of yes minus p of no. Class 2 mathematics. Yes. Okay. So why don't to do a encoding for the categorical when using? Why don't we do a encoding for the categorical when we are using a decision tree? Because decision tree itself will be able to handle your categorical data. Then why to do a why to find out, or why to convert something into encoding? So we try to convert something into by using an encoding if there is a numerical value which is required. Here we just have a, so Gini can work with the categorical, right? So I have taken male, female, male, female. So it is going to work with that. So there is no meaning of doing an encoding in case of a decision tree. Hope this answer is clear. Could you tell if my understanding is correct? After selection of the root node, we need to consider the same teacher again for the child classes. Yes, in general, we do consider, and we recalculate a Gini for that as well. If I'll talk about like a algorithm part wise, when to use logistic regression and when to do a decision tree, you will get your answer. I think I have already answered this question. Fine, moving ahead. So this is one of the way by which we can create a decision tree. So now if I'll give you a data set and if I'll ask you to create a decision tree manually, I believe you all will be able to create it, right? In case of a categorical data or this kind of a data set, if I have given to you, maybe with the 10 columns, yes, we all can calculate, or we all will be able to create this kind of a decision tree. That's completely fine. Now, with the help of same data set, so we are going to build again a decision tree. Same data set. I'm not going to change a data set at all. So we are going to build a decision tree, and we will try to understand. So we will try to understand that how, by using a complete different mathematical approach, we can build a decision tree again. So anyone who thinks that no, I will not be able to build a decision tree by using pen and paper. I'm not talking about the code wise. So in one line is possible. Nilesh, I have already given your answer. Yeah. So how many of you think that I won't be able to create? I'm just waiting for your answer, all of you. Okay, Mohit is thinking that he can't create. Fine. Okay, we can create. I am okay. Looks like this generally doesn't require a data to be linear, right? No, not at all. Only for a limit can do now able to create. With Gini we can. Okay. So fine, most of us will be able to create, some of us will not be able to create. Maybe some of us requires some sort of a revision in this same step-by-step manner. The way we have calculated it, it requires a little bit of practice. Yes, David. So it requires a little bit of practice, but we all will be able to calculate it, right? Again, the beautiful things about this one is that even with the complex data set, right? So where you are not able to find out maybe some linear relations or some sort of a proper shape of the data, even in that place, you can try to use a decision tree and it is going to work well, because what it is trying to do, it is trying to just create a separation. So separation, I can try to create even with the zigzag kind of a data set. Can I say that? So can I say that we have this zigzag kind of a data, right? Completely unshaped data set I have. Yeah. So completely unshaped data set I have, as you can see. So will you be able to draw a line over here? to create a separations? Will you be able to draw a line in this to separate this data, right? Ideally, it's not possible, right? Ideally, it's not possible. So if I ask you to solve this, solve like this kind of a shape of the data set we have, and if I'll ask you a question that, can you please solve this problem statement, or can you please solve this classification problem by using a logistics? Will you be able to solve by using any solver? No, right? But is it possible to make if-else kind of a statement and keep on dividing a data set unless and until I'll not be able to reach out to the final layer? Is it possible? Yes. So that is the advantages you will be able to get over here as compared to logistic regression. In case of a logistic regression, we are drawing the straight line, right? So like with the simple data set, with the linear data set, it is possible to go ahead with the logistic regression. I can create a line and I can separate a data set, and then on both hand side of the line, so I will be able to find out the probability, one class or other classes, or one class or rest classes. But wherever we are not able to create a very clear separations, in that case, decision tree you can try to utilize, and that's a beauty of using a decision tree over to your logistic regression for a classification problem. Again, if I'm talking about a regression, so linear regression is going to work well if your data set is linear. But let's suppose if I have given you zigzag kind of a data set, will you be able to fit a line on top of that? The answer will be no. You can't fit a line on top of those data set. But here, for sure, you will be able to create, and you will be able to create a regressor decision tree over there. And based on that, you will be able to do a calculation. So how we can create a regression decision tree? We'll try to discuss. First of all, let's try to understand our classification part. But this works well in both the cases, regression as well as classification. So both the tasks, I will be able to do it, and that too with the complex data set. So can I say that this is more powerful algorithm as compared to the previous one that we have discussed? Yeah. Okay. Now here, right? So let's try to understand the same problem statement. We can try to solve with the same data set, but by using a different approach, right? And then we can try to decide that, okay, fine, so whether we should go ahead with this or that, in what circumstances, in what cases we are supposed to go ahead with the Gini or the other one, which I'm going to discuss now. So the other approach that we are going to discuss, again, there will be a calculation. So be ready for a calculation and try to pay your attention for next, again, 45 minutes. It will take 45 minutes to 1 hour of time to do all the calculation, right? And then you will be able to create a tree. So here, right? So here what we can do is, so maybe we can try to take a same data set that we have taken over here, right? Similar, exact same data set. And then we can try to do a calculation, but this time by using entropy and information gain. Information gain. So anyone who can explain me what is the meaning of entropy from your chemistry class in 9th or 10th? Entropy? I think we all have studied this term called as entropy in a chemistry class, right? Probably in 8th or 9th, somewhere in 8th or 9th. Yes. So whether we are from a CBSE board or maybe from a ICSE board, but we all may be from a state board, local board. But yeah, so we all have studied entropy, right? This is what I remember. So when I was in class 9 or 10, so I think I have studied these things, right? So entropy is called as, in other word, in a very simple word, it's called as randomness, right? Or it is called as maybe in terms of a degree of freedom. बस ये नाम याद है, बाकी कुछ भी नहीं. It happens. Same thing happens with me. So fine, I'll just show you two sample over here. So let's suppose we have two containers. We have container number 1 and we have container number 2 over here, right? Okay. Now in this container, we have some kind of a substances. So I don't know what, maybe sugar or salt or something, you can try to consider. container number 1, container number 2. Who is having high entropy? Everyone is telling me container number 2. Some of you, I think 1 or 2 is telling me container number 1. Now, what is the, again, some of you, those who are saying container number 1. So I just asked you one simple question, that container number 1 and container number 2, I've just drawn 2 figures over here. And I'm just asking you a question. So who is having the high entropy? It simply means that who is having the very high randomness, right? Or a scatteredness over here, or maybe a degree of freedom over here. So can I say that container number 2 very clearly? So it's a container number 2, which is having a high randomness or high entropy, I believe, right? So because over here, degree of freedom is very high in container number 2. So if this molecule or atoms, whatever you say, right? So if it will try to move, so for sure it will be able to move more freely, right? As compared to in a container number 1. Can I say that? Yes. Yeah. So again, I can give you another example, right? So like, let's suppose I have a cylinder, right? So in a cylinder, so let's suppose there is a 2 cylinder. So in one cylinder, I have like a cylinder filled with 1/4 of any of the gases. And in another cylinder, so I have like a gas filled till like a 2/3 mark, right? So which one will be having the high entropy? So can I say that a cylinder which is filled 1/4 will be having the high entropy or high randomness or high space for a movement, right? Or high degree of freedom, right? So you can just compare. This is the things, this is the definitions that we have studied in our childhood. So again, I'm just talking about the same definition, nothing new over here. So entropy always tells me that, okay, so which is having the high degree of a freedom, high degree of a freedom, or which is having the highest flexibility for a movement. This is what a meaning of entropy is. So anyone who can tell me what is the formula for entropy? This is the meaning of entropy, right? What is the formula for entropy? Can I say that generally we try to write entropy is equal to, so minus of P log of P. This is something called as entropy. This is the formula of entropy, right? So maybe summation of all I can try to take, right? But in general, if I'm trying to write the entropy, so it's nothing but minus of P log of P, summation of that. So that is something we can try to discuss, or that is something that we can try to decide, right? So here what we are going to do is, for a given data set, we will try to calculate an entropy, right? We can try to calculate an entropy, and then based on the entropy, we can try to calculate information gain. Now, what is this information gain? So let's suppose I have taken a data set. In my data set, I have 2 columns. One is the class column, one is a gender column. I have 2 columns, right? Now, when I have a 2 column, so let's suppose I have taken a class column, right? And then I'm trying to find out the entropy. And then I have taken a gender column. And again, I'm trying to find out the entropy. Then based on maybe an entropy, high or low, we will decide in a later stage as like a Guinea impurity. So if Guinea impurity is low, so in that case, I was trying to make that as a that as a root node. In case of this one, what happens is, so we'll try to calculate the entropy before and after creation of a tree. So information gain is nothing but it's a difference between an entropy. So the information gain that I'm going to write over here. So what is the informations you will be able to gain after and before creating this, or after or before creating a tree, or after and before dividing a data? That is something labeled as a information gain. So based on this, right? So based on this, we can try to decide entropy. Maybe I can say like before minus entropy after, or vice versa. In a very simple way, if I have to write. So after creating a tree and before creating a tree, so what is a entropy or differences I'm able to find out for a particular attribute? That is something called as information gain. So it's always tells me that, okay, fine. So which is giving me a less differences, or let's try to decide. Let's try to decide after doing some sort of a calculation in a later stage. so that we'll be in a better position to talk about each and everything. Okay. So let's start talking about the same data and let's start calculating a entropy for everything. So let's suppose, right? Let's suppose I'm going to I'm going to write a very small statement over here. So here, if I'll say, how many total number of instances we have? Can I say we have in total 14 instances or 14 record, right? Out of 14 record, how many of this record is giving you yes as an outcome? Because we have two classes, 14 record, we have two classes, right? So if I look into my final label class, so how many a data set we have with respect to class yes, and how many data set we have with respect to class no? Any idea? So I believe with respect to class A, yes, as you are saying, so we have 8 data set, and with class no, we have 6 data set. I think we can go back and we can confirm, right? So how many yes we have? So 1, 2, 3, 4, 5, 6, 7, 8, right? So remaining will be no for sure out of 14. So 8 data set we have, which is giving me yes, and then 6 data set we have, which is giving me no over here. I will try to create a entropy. I will try to calculate an entropy for yes as well as for no. I'll try to calculate for my final label column, let's suppose. So if I have to create an entropy, so if I have to calculate an entropy for a label column, right? Or maybe I can say like who is going to stay in hostel and who is not going to stay in hostel. So entropy for a label column, I'm going to write in this particular place. So what will be the entropy? So can I say that entropy is nothing but probability of yes log of probability of yes, because we have two classes, minus, because it's a summation of I is equal to 1 till C. C is nothing but number of classes that we have. Then minus probability of no log of probability of no. Is it correct? Can I write this formula for entropy? Yes. So I believe we can write a formula for entropy. Just a randomness I'm trying to find out. I'm trying to find out randomness for label column. Very simple, right? Okay. Now, what is a probability that we have yes? What is the probability that we have yes? So can I say that out of 14 data, 8 data is yes, right? So can I say that P will be nothing but 8 by 14, 8 by 14 log of 8 by 14. What is our data set? What is the probability of no? So can I say that 6 by 14 log of 6 by 14? Agree everyone till this point? Yes. So what is the total number I will be able to get? A final number? Any idea? So anyone who can do a calculation? So log of 2, base 2. So try to do a calculation based on base 2 because it will be like a base 2. What will be the entropy? Anyone who can do a calculation for me? Okay, so Ajit is saying 0.98, 0.98522. Okay, so it is going to be 0.98522. Answer given by Jaspreet. Yeah, Nitin is also saying 0.98. So fine, this is the value that I will be able to calculate. I think you all have a calculator, so you can also do a calculation from your end. So those who are confused. So this is the value that I will be able to get. So anyone who is having any issue with the things which I have written? Yes, no, or maybe don't know. No? Okay, moving ahead. Fine. So we are able to calculate a entropy. Entropy of what? My label column, I'm able to calculate. Fine. Now what we can do is, so maybe we can try to calculate a entropy, right? So we can try to calculate an entropy for maybe a columns. Class column is there. Gender column is there. So we can try to calculate an entropy for a class column. We can try to calculate an entropy for a gender column, there is a very high chance because we have to calculate it. This is the entropy that we have calculated as of now for a final label column or kind of a decision making column, you can say. But if I'm going to calculate entropy for like let's suppose class 8, class 9, sorry, inside a class column. So again, we have a class 8, 9, 10, 11, and maybe we can try to calculate an entropy for each and everything, right? Okay. So let's try to understand, or let's try to calculate it. So if I will try to calculate, right? So let me take a new page over here for class column. So again, we can try to consider this entire table, the table that we have created. Same old table we can try to refer over here. So class 8, 9, 10, 11 inside a class column we had, and stay in hostel 2, 1, then total value is equal to 3, probability is equal to this. So it's the same table that we can try to utilize. So if I'm going to calculate entropy for class 8, what will be the entropy for class 8, by the way? Just for class 8. So what is a probability of like a person to be in class 8 with yes? Please mention in a whiteboard, it's a log 2. So yes, I have already mentioned, as you can see, log 2, right, in my main formula. So I have already mentioned. Here it's mentioned. Okay, fine. So now if I'll ask you, so what is entropy or entropy of the class column we are going to calculate, right? So what is entropy of a class column for 8 class? So can I say that minus of probability of a person who is in class 8 and yes, his or she is going to stay in hostel, right? So can I say that it will be nothing but 2 by 3, right? Log of 2 by 3 minus 1 by 3 log of 1 by 3. Agree or disagree with this one? Is it fine? Are we agreed on this one? Yes, because if you will look into this table that we have created, so there are total 3 data, and out of this 3 data, 2 is yes, 1 is no. So fine, entropy of class 8 is this one. So class 8 is this one. Now entropy for class 9, right? So in class 9, what we have? So 2-1 ratio we have, right? So out of 3, so fine 2 by 3, 1 by 3, it's going to be same. So minus of 2 by 3 log of 2 by 3. All calculation you are supposed to do on base 2. 1 by 3 log of 1 by 3. Now entropy with respect to class 10 for a class column. So it is going to be what? It's 4, so 1 and 3, right? So minus of 1 by 4 log of 1 by 4 minus 3 by 4 log of 3 by 4. Entropy for class 11. So what is our data set? We have, so 3, 1, 3 yes, 1 no out of 4. So it is going to be 3 by 4 log of 3 by 4 minus 1 by 4 log of 1 by 4. Okay. Fine. Now, so what is the calculation? So calculation will be 0.918, 0.918, and here, so it will be 0.811, 0.811, 0.811, 1. So for a class column, we are able to find out entropy for all the 4 attributes. So whatever attribute that we have, so for all the attributes, I'm able to find out, right? This one. Now there is no issue. So we are able to find out. Now let's try to calculate. So this is the entropy, right? Last time we were calculating a Gini, and based on that, so we were trying to calculate a total Gini. So this time what we will do is, so we will try to calculate what? So we'll try to calculate the entropy. Now, once I will be able to calculate the entropy, so I'll try to calculate a information that I will be able to get from the class. So information that I will be able to get from the class is nothing to total column, right? Because inside this class, we have 8, 9, 10, 11. So separations wise, we are able to find it out. But for a total class, if we have to calculate this one, informations that I will be able to get from this one, if I'm going to separate this class, because this is the separate one, right? So I have to calculate the total information. So total information from a class column, total information from the class column that we are going to receive is nothing but, so in class 8, how many total data is there? Class 8, for class 8, what is the total number of data? 3, right? Out of how many data set? 14. What is the entropy? 0.918 plus in class 9, how many data set we had? Can I say 3, right? Out of 14. And what is the entropy? 0.918. In class 10, how many data set we had? So I believe 4. Total 14 into 0.811. Plus in class 11, how many total data set we have? So we have like a 4 by 14 into 0.81811. So this calculation will be equal to 0.8574, right? So this is the calculation that you will be able to find out. So what is a total gain of a class after finding out the individual categorical entropy? So can I say total gain is equal to 0.8574? This is the gain that I'm able to receive, or this is the information which I will be able to receive over here. Now, what is the formula I have written for like information gain? So can I say that the formula which I have written for information gain is equal to nothing but, so like a entropy which was there before and entropy that we are able to find out. Now, what is the meaning of this before? So before means what is the entropy of your final label column? So what is the entropy of my label column, by the way? That is my actual distribution of the data set, right? That is my actual distribution of the classes. So what is a entropy of my label column? So can I say that here is an entropy of my label column? So can I clearly mention over here that this one is an entropy of my label column? This will be my final entropy, right? And what is a information gain I'm able to receive once I will be able to separate my data based on the class columns value? When I'm trying to separate the data based on 8, 9, 10th, 11th, I think we have done that last time, right? So what is a gain which I'm able to receive? Means what will be the entropy? What will be the total entropy, total informations I will be able to receive? So can I say that 0.875? So what is a information gain? Information gain is nothing but the entropy, original entropy, or by default entropy for my final label column, which is nothing but 0.98522 minus entropy after. So if we are taking this one, if we are trying to divide our data set based on this attribute, based on this particular column, so then what will be the entropy? So or information gain, so 0.8574. So what will be the total information gain over here? So can I say that total information gain is 1, 2, I believe 7 something, right? So 1, 2, 7, 8 or something like that, I will be able to get. So this is the total information gain. Means this is the total difference between the entropy which is available in label column and entropy or maybe total information I will be able to get if I'm going to divide my data based on this class column attribute. Is it fine? So our final things was to calculate a information gain. How we are calculating? Is it fine? So information gain we have calculated only for what? Information gain we have calculated for a, can I say, for a class column. Is it fine? Class column, right? Similarly, I will try to calculate information gain for what? So information gain I have to calculate for maybe a gender column. Gender column. So how I will be able to calculate an information gain for the gender column? So I believe we already have this data, right? So gender, male and female, and then the strain hostel, like a 5333, and all those things, right? So how we can try to calculate? So if I have to calculate this one, so first of all, inside a gender, so what is what is the separation I can create? Can I say male and female? So entropy for male, I will try to calculate. So what will be the entropy for male? So how many? What will be the entropy for male, by the way? So can I say that in a male, right? We have 5 yes, 3 no, right? So entropy for male is equal to, so 5 yes and 3 no. So can I say that it is going to be 5 by 8 log of 2, 5 by 8 minus, so 3 by 8 log of base 2, 3 by 8. Fine. Entropy for female. So what will be the entropy for female? Just for female. So 3, I believe, right? Okay. So entropy for female is nothing but 3 by 6 log of 3 by 6 minus 3 by 6 log of 3 by 6 for yes as well as for no. So what will be the outcome? So can I say that this will become 1, right? Log of 1 by 2, 1 by 2, log of 1 by 2, 1 by 2. And this is going to be 0.954 given by Supreet. Yes? Okay. So entropy for male and entropy for female, we are able to calculate. What is next that we are supposed to do? So thanks, Ranjan. Yeah. So what is the entropy that I will, so what is the next step I am supposed to do? So entropy of gender, inside a gender column, we have 2 things, male and female. So for male, we have calculated, for female, we have calculated. Now, can I say that entropy or information for a gender column, we are supposed to calculate for the whole column? Information for gender, we are supposed to calculate, right? So what is the information for the gender column? I will be able to calculate. So information for a gender column, if I have to calculate, so what is the things which I am supposed to write? So what is the total number of male? So what is the total number of male? 8 by 14, right? 14 into entropy of this one, 954. What is the total number of female we had? 6. Out of what? Out of 14 into 1. Now what will be the final calculation? Yes. So 0.973, or I think 0.974. Fine. 974. So fine. Information for a gender column. So what is the information I will be able to get if I'm going to divide it by using a gender column, and where inside a gender column, so I have male and female. Now information gain I'm supposed to calculate. So how I will be able to calculate a information gain over here, because that was the objective, right? Calculating information gain for a gender column, because for a class column we have already calculated. So what is the information gain for a gender column? So can I say that again before and after? So what is the original informations or original entropy that we have? So can I say that original entropy I can get from the label column, the final column, the class column? Yes. Yeah. So entropy of the label minus entropy of the gender. So what is the entropy of the label column? I believe we have already done the calculation. Entropy of label is 9.58, 0.98522. So 0.98522. Once we are going to separate my data based on the gender, then what will be the informations? 0.974. So what will be the differences over here? So can I say that 0.01 right? So if information gain of gender is equal to 0.01 and information gain of class column is equal to 1278. So information gain of class column is 0.1278, right? So one is for a gender column and one is for class column. Now, whose information gain is more and less? So can I say that if I'm going to pick and choose, right? If I'm going to pick and choose the class column, so I'm able to get more information gain as compared to a gender column. Yes. So gender column is having a less gain, class column is having more gain. Now more gain in terms of what? More gain in terms of whatever data set is given to me for which label column is given, right? So whatever entropy is available and whatever entropy, so now try to understand this factor, right? I'm going to unshare my screen. Just try to understand this factor. See, what we have done. We have calculated entropy. What entropy represents? Entropy represents randomness. Can I say more entropy, more randomness, less entropy, less randomness? Agree, disagree? Yeah. So more entropy, more randomness, less entropy, less randomness. Fine. We understand this definition. Definition of entropy that is already available inside that was already available in our chemistry classes, right? Now here, what we have done. So we have calculated a total information gain of a class, right? Class column, gender column. Inside the classes, we have a multiple attribute. Now, when we were trying to calculate the info, and we have done a same thing for even for the label column, right? Even for the label column, so we have done the similar kind of calculation, entropy, entropy calculation we have done. That I'm saying as a before. So before, so means in our original data, we have, let's suppose, entropy is equal to 100. Yes, randomness is equal to 100. When I'm trying to use class column, right? When I'm trying to use a class column, so let's suppose that is giving me entropy is equal to 70. Means total gap is equal to 30. So entropy is equal to 70 giving me, so class column is, can I say that class column is going to stabilize my data? It is going to decrease my randomness. If I'll try to compare the things with my label column is having more entropy, right? That was before. After, so when I've tested with the class column, so it is giving me less entropy, right? So it is also randomizing my data, but it is creating a less randomization. It is creating a more clear separation. Can I say that? Can I make this statement? Yeah. Now, so there is another column, right, which is also trying to create an entropy, but it is closer towards, the original one, which is a gender over here. Means it is also like having a differences, means it is also creating a less randomness as compared to a label. But who is creating a less randomness? So who is creating a minimum randomness? Can I say it's a class column which is creating a minimum randomness? Yes. That's the reason. So we have a high information gain. So which one I'm supposed to select? Someone is saying no, I don't know why. So can I say that class column is creating a less randomness? Yes. So which column I'm supposed to select, whether it's a class column or whether it's a gender column I'm supposed to select. So a column which is creating more randomness into my data, or a column which is creating high randomness into my data, class column, right? For sure, which is creating a less randomness. And that is the answer which we are able to get from an information gain very easily. So information gain is just a difference, nothing else, nothing much, right? So that is the reason. So here we always try to select that particular entity which is giving me high information gain. High information gain means less, more differences in between before and after entropy. Are you able to get your answer? Yeah. So low entropy means high purity. High purity means like less degree of freedom. Simple. So high entropy means high degree of freedom. So class is giving me less as compared to like a gender column in terms of entropy. In terms of information gain, it is having high. Class is giving me high information gain because difference is more, right? So it's like a very, very simple, and that is the reason. So in case of information gain, we always go for high. In case of Guinea impurity, so if you will just try to like understand this thing. So both is actually same. So Guinea and entropy. So you can compare Guinea and entropy over there. After calculating information again, I'm saying that no, so we are supposed to go ahead with the high information gain. But if we'll compare Guinea and entropy, so actually we are going ahead with the less impurity, less entropy. So less Guinea impurity and less entropy. Is it making sense? So actually it's same in that way. Yes. So these are the two ways by which we can try to build a decision tree. So can I say again over here that finally we are able to select a class column as a parent column. Agree? Even from here. So can I say that by using both the approach, a Guinea approach and information gain approach, we are able to conclude a same thing mathematically? Yes. So we are able to conclude a same thing. So whether you are going to use a Guinea or you are going to use an information gain, things is not going to change. Now the only matter of fact is now we have to find out which one we are supposed to use in what circumstances. Calculation wise, I think we are good. But still we are not able to find out that which one is supposed to use with the categorical data, with the continuous data set, and some other small factors. What is how we can try to introduce a regularization in decision tree. We know about regularization in logistics as well as in case of a linear regression, but how we can achieve a regularization so that I can stop overfitting of the data. I think we are not aware about those concepts yet. We can try to understand those things. So I think I believe this is a core concept. This is a very, very important concept. The reason behind this one is we are going to use a decision tree even in case of a random forest. So next time I'm not going to explain you decision tree. I'll simply explain the concept of random forest because I have already explained you how trees been created. So random forest is nothing but it's a combination of a multiple trees. That is something called as bagging method, or it's part of your ensemble technique. That is fine. So now I think I can take a question. Sir, can we calculate information gain with respect to a Guinea? No. So to calculate information gain itself says that I'm a difference between before and after entropy. This is the information gain. It's just a difference between before and after entropy. So why you are going to use Guinea in that case? Why we did a summation of entropy of an individual element of the class column while calculating information gain of the class. So inside a class, we have a multiple categories. So for individual categories, we have done the calculation, but for on a class level, we have to do a calculation, right? That's the reason. So we have done the summation. So we have to find out this one. We are interested into information of entire class, not just one attribute of the class. Means class feature has less randomness and high information gain. Exactly, yes. This is what we are trying to conclude. How we will build a tree here in entropy and information gain particularly. So I think in case of Guinea indexing, I have already told you, same thing will happen. So once I'm able to find out that class is going to be my root node, so I'll create this one, same. Then I'll divide our data, same. Now this time again, we will try to calculate what? Entropy and information gain. Yes. So information gain of this one, we will try to calculate information gain of this, and we will try to compare with the information gain of this one and this one, or in gain of this and this. It's the exact same thing. So recursively, you will keep on doing these things unless and until you are not able to go till a final node, or that is called as leaf node. How does entropy criteria related with the decision making? I think this is what I was trying to understand, explain you, right? Since last 1 hour. Figure 1 has a less entropy for a figure 1 that is good for a model. Figure 1 has a less entropy for figure 1 that is good. Like, what is figure 1, by the way? Like, are you talking about this figure of container? Container 1 and 2? Okay. So yeah, figure 1 has, no, this is a question I just missed out. Figure 1 has less entropy for a figure 1 that is good for a model. Yes. So we have a less entropy over here. We have a less randomness over here, so that my result will be, or whenever I will try to do a prediction or forecasting, it will be more accurate. See, if you have a very scattered data, right? Let's suppose I have given you this kind of a data, right? And I have given you one, and then so this is column x1, this is column x2, this is column x3. So 1 and then 2 is equal to let's suppose 0.4, 2 and 5. So 2 and 5 is equal to 0.8. And then if I'll ask you a question, so what will be a result of 100 and 101? Will you be able to give me answer? Will you be able to find some pattern? No, right? Because your data set is very random over here, right? So that is effect you will be able to get even with respect to this one, container number 2. This is what I was trying to explain. So if your data set is very much random, so in that case, for sure, you will not be able to conclude. So in similar way, you will not be able to make a separations in case of a decision tree, and you will face a problem in terms of giving a prediction forecasting. But I think the randomness or entropy of the column should be more in terms of avoid a overfitting. First of all, try to find out what is the meaning of overfitting and underfitting, right? Then, because you are talking about overfitting in a wrong sense over here, right? So overfitting, underfitting depends upon your final model that we end up building. So no, I think your concept is not clear. Whileness Guinea is good for the root node. Guinea is called as Guinea impurity, right? So here we are trying to do find out a Guinea 1 minus probability. So probability of occurrence of one of the classes. So if it is very, very like a high, so in that case, your total information gain is, so probability of occurrence or randomness of one of the classes is very, very high. In that case, total impurity will be less. So that's the concept behind that. I'll be using log base 2 because they are only log 2 parameter in our data. Only 2 parameter in our data set. So if I'll give you like 100 columns, so in that case, Naveen, what you will do? You will try to use log of 100. Just the calculation, right? And topic calculation happens on this one. So answer is no. It will always be log base 2. Why it is not used for the continuous data set? I'll be talking about it. I told you very clearly that I have not discussed about when to use, when not to use. I just talked about the mathematical concept. First of all, digest this. I'll talk about each and everything. Is agenda for today is completed? Yes, from my side, it's completed, because if I'll start explaining you about more and more things, I believe you people will get confused, and this is a very important concept. And the other concept which I'm going to discuss, it's equivalently very, very important, because I have to talk about regression based on the similar concept. Plus, there is something called as loco CV. There is something called as cross validation. There is something called as K-fold. There is something called as bootstrapping. There is something called as pruning or regularization of the tree. So all these concepts are like a kind of a concept which people will ask you directly in an interview, right? So that's the reason I'm afraid if I'll discuss everything, then you will not will retain. When we use Guinea and when to use information again, same question. Okay, so I think I'm done with today's class, right? So just try to retain this concept, because your decision tree is completed just by, I believe, 30%, 40%, 30%. Yes. So 70% is there. Still it's there, right? So we are yet to discuss a 70% of a decision tree, which we will discuss in your next class, right? Go take rest, do your homework, plus try to digest this entire things. Guinea, entropy, information gain, plus calculation. So that if someone is asking you, explain, you should be able to explain by taking some dummy data set, right? So 70% of math or code. Out of this 70%, 50% is code and 50% is still a math. Out of that 70%. So yeah. because in like this my explanation, almost 70% will be a mathematics, 30% of code. So code is like we can do it. Still confused how to calculate for the continuous data set? Yeah, you are confused because I have not discussed. Once I'll discuss, that's the reason I'm saying that still there is a pending topic. So once I'll discuss, I think you will be able to get that answer as well. आज के लिए बहुत, yes, picture ही बाकी है. So just wait, right? So I'm not going anywhere. I believe you are not even going anywhere. So we'll again meet and then we'll again try to discuss. The whole idea is to clarify a concept till its uttermost labor, so that we should not have any kind of a confusion, right? And clearly we'll be able to give an answer in an interview. So we are not learning so that we can import some libraries and pass our data and then we can try to build a model. We are learning so that for a lifelong, so we will be able to utilize it. And first of all, in an interview, so we have like some different purpose, right? We don't have a purpose like, okay, fine, solve a Kaggle problem. Yeah. So what is the support that you're looking for? Many times. Have a great evening. Thank you. Start here. Okay. Yesterday you gave a logic regression task. There are so many Excel files. We have to merge them in a single Excel file. Yeah, you have to merge them in a single Excel file. And even I was shocked when I have seen some of your like a solution. So I have given you a task yesterday, and yesterday night itself, right? Yesterday night itself. So I have received some of the mail. I have seen some of the mail. So where I have seen a solution. I'll just show you one, right? So it is from like a kirtan, and he has done these things beautifully. So see the activeness. Again, I have a multiple mails. I'm just going to show you one. Task completed. Then I have just like dropped him a mail and said that try to like go for a deployment. So this is something called as activeness, right? This is what, yeah, Kartben, KRTHBM. Oh, it's like Kartben. Okay, yeah, please go ahead. I can see your hi. So, yeah, Rich has submitted today. Okay, I'm like yet to check your solution. So, this is something called as completing a task, right? Person has done that. So, in total, there was, I believe, 41,000 record, right? Yeah, 41,757 record. So, this is the final record that has been created, and based on that, so like remaining procedure has been performed. So yeah, I'm looking for a participation from all of you, not just from couple of you. Classification task, there are so many Excel files, we have to merge them in a single file. Yes, indeed, Vivek, we have to merge them in a single file. I believe person are doing it, right? So I believe even you can do it. Why not followed login? So I have already asked them that, okay, so go for the production. So at that point of the time, I think person is going to follow everything. Is DBC task still active? Yeah, task given by me will be active unless and until you are not going to submit it, right? So there is no deadline. Generally, I used to mention, yeah, sometimes I give a deadline, submit in 2 hours, 3 hours, but still, even after 2 hours, 3 hours, even after 1 week, if you submit it, like I reply back to your mail, I believe, right? I've already replied. I always replied back to your mail. So I'm just looking for your participation. Simple. So we are here to, like, at the end of the day, we are supposed to be in a situation so that we can work in any kind of a problem statement, and for that we are like trying to do a preparation. Okay, so fine, guys. This is it from my side. 70% is still pending from your decision tree, right? Mathematically, theoretically, everything wise, right? 30% is the only things which I have covered in today's class. I believe you all are able to understand it. You all have enjoyed, right? You all have learned something new today. The task, entertain tasks from the recorded sessions, and you also entertain tasks from the recorded session. I don't think so. Task we have implemented both DBC and MLflow, or anyone is enough. I believe anyone is enough, but if you can create both, I will be like happy. Simple, right? So fine, guys. Thanks everyone. Thanks Jareen. Thanks Devasis. Thanks Lucy, Supreet, everyone. Sukesh. So let's see. Like Saturday, next Saturday class. So I'll try to extend the same thing, and we will end up like doing some implementation as well. I mean, I joined late, so task given earlier. Yeah, so you can complete it. See, even if you have joined late, right? So from a recorded session, so whatever session which I have already delivered, so I have given so many tasks, right? I remember all the tasks. You can create a solution, send it to me. I'll evaluate. Don't worry. Yeah. So Anuja, I think your query is clear. Yeah. Okay. So fine with that. Thank you so much. See you again in your next class. Have a great day, night ahead and end of your today's class. Thank you so much.